What are the essential divisibility rules for quick math? Imagine trying to figure out if one number can be divided evenly by another without doing long division every time. That's where divisibility rules come in. They're like shortcuts that help you check quickly. These rules are part of understanding division, a core mathematical operation, and they connect to fundamental number concepts. Let's explore some of the most useful rules that make math faster and easier. First, if a number ends with 0, 2, 4, 6, or 8, it is divisible by 2. This is because these digits are even, and even numbers are multiples of 2. For example, 124 ends with 4, so it's divisible by 2. Next, for divisibility by 3, add up all the digits of the number. If the total is divisible by 3, then the whole number is divisible by 3. For example, 123 has digits 1, 2, and 3, which add up to 6. Since 6 is divisible by 3, 123 is divisible by 3. For divisibility by 4, look at the last two digits of the number. If those two digits form a number divisible by 4, then the entire number is divisible by 4. For example, 316 ends with 16, and 16 divided by 4 equals 4, so 316 is divisible by 4. When checking for divisibility by 5, look at the last digit. If it ends in 0 or 5, then it is divisible by 5. For example, 145 ends with 5, so it is divisible by 5. Divisibility by 6 requires the number to be divisible by both 2 and 3. So it must be even, and the sum of its digits must be divisible by 3. For example, 132 ends with 2, making it divisible by 2, and the sum of digits 1, 3, and 2 is 6, which is divisible by 3. Therefore, 132 is divisible by 6. Now, for divisibility by 7, the rule is a bit trickier. Double the last digit and subtract it from the remaining leading part of the number. If the result is divisible by 7, then the original number is divisible by 7. For example, take 203. Double the last digit 3 to get 6, then subtract 6 from 20, which gives 14. Since 14 is divisible by 7, 203 is also divisible by 7. To check for divisibility by 8, look at the last 3 digits of the number. If those 3 digits form a number divisible by 8, then the entire number is divisible by 8. For example, 12,344 ends with 344. Since 344 divided by 8 equals 43, 12,344 is divisible by 8. For divisibility by 9, add all the digits together. If the total is divisible by 9, then the number is divisible by 9. For instance, 729 has digits 7, 2, and 9, which add up to 18. Because 18 is divisible by 9, 729 is divisible by 9. Divisibility by 10 is simple. If a number ends with 0, it is divisible by 10. For example, 560 ends with 0, so it is divisible by 10. For divisibility by 11, subtract the sum of the digits in the even positions from the sum of the digits in the odd positions. If the result is 0 or divisible by 11, then the number is divisible by 11. For example, in 2728, the sum of digits in odd positions is 2 plus 2, which equals 4, and the sum in even positions is 7 plus 8, which equals 15. The difference is 15 minus 4, which is 11 divisible by 11, so 2728 is divisible by 11. Finally, for divisibility by 12, the number must be divisible by both 3 and 4. So, check if the sum of digits is divisible by 3 and if the last two digits form a number divisible by 4. If both are true, then the number is divisible by 12. Knowing these rules helps you quickly see if one number can be divided by another without doing full division. They connect to the idea of breaking numbers into smaller parts evenly, which is at the heart of division and understanding how numbers work together. These simple tests make mental math faster and help you see patterns in numbers more clearly.